بسم الله الرحمن الرحيم. أعزائي طلبة وطلبات شهادة الثانوية العامة قسم رياضيات لغات، أهلا بكم. اليوم سنتناول درس جديد في مادة ديناميكا. طبعا احنا عارفين مادة ديناميكا مادة مهمة جدا، هي إحدى فروع المادة التطبيقية، معها مادة الاستاتيكا. وكما علمنا من قبل أن الديناميكا هو علم الحركة، أما الاستاتيكا هو علم السكون. Welcome, my dear student, in our math program for second 3. Today, we are taking new lesson in dynamic. It's called the relation between V, V naught, S, and acceleration A. My dear student, relation between V naught, V, A, and S. My dear student, look at the graph represent the relation between velocity and time. V naught, what is the meaning of the V naught? V naught initial velocity, V final velocity, T is time. Uniform variable, A equal constant, A is acceleration. V minus V naught over T is acceleration. V minus V naught over T equals acceleration. V equals V naught plus AT. If V minus V naught over T equals A, therefore we deduce that V equal V naught plus AT. This is the first rule. The final velocity equals initial velocity plus product of acceleration times time. My dear student, sum of area, look at in the opposite figure, equals V naught T plus half multiply bracket contains V minus V naught times T. S equals V naught T plus half multiply bracket contains V minus V naught times T. Then we deduce that S displacement is equals V naught T plus half AT square, the second rule. Very important rule, clear that relation between S, V naught and acceleration with time T. If we the required displacement S or distance and the given V naught time acceleration, we use this rule. This rule very important. S equals V naught T plus half AT square. If we have from given displacement S or the distance and V naught and the time, the required is A, we can use this rule to find the value of acceleration A. My dear student, square 1 and subtract in equation 2. We deduce that the relation between V final and initial velocity and acceleration with displacement S. This rule, the third rule, V square equals V naught square plus 2AS. My dear student, V square equals V naught square plus 2AS. We have four unknown, V square or V, V naught, acceleration A is the distance. The required one of four unknown, the given three known is V, V naught A, then the required S. If the required V, the given V naught A and S. This rule, the third rule, V square equals V naught square plus 2AS. Example, my dear student, look at particle move with acceleration 2 meters per second square. A particle moves with acceleration a equals 2 meter per second square. Initial velocity v naught equals 5 meter per second. What's the required? Find final velocity after t equals second, distant after 3 seconds. Look at the solution. My dear student, v after t equals 7, by substitution in first rule, v equals v naught plus at. From the given, v naught equals 5, acceleration 2, substitution about t equals 7, then velocity or final velocity equals 19 meter per second. Distant after 3 seconds, we use the second rule, as equals v naught t plus half at square. By substitution about v equal 5, v naught, t equal 3, acceleration e equals 2, then the distance after 3 seconds equals 15 plus 9 equals 24 meter. This rule, distant s equals v naught t plus half at square equals 24 meter. My dear student, now we are translate to another example. Find the velocity when a particle moves with acceleration 3 meter per second square, v naught equal 4 meter per second, when covers 10 meter. My dear student, if we have particle moves with acceleration 3 meter per second square with initial velocity 4 meter per second, what is the final velocity when cover 10 meter? What is the suitable rule when find the final velocity? Look at the solution. The suitable rule, my dear student, the third rule, v square equals v naught square plus 2as. Why? Because we have 3 given, v naught, a acceleration and the distance. By substitution, v naught square equals 16 plus 2 times 3 times 10, answer is 76. This is v square. But the velocity, positive or negative, square root 76 meter per second. Another example. Particle moves from A to B. We have 2 points and t time the first at the first point 3, the second at second point t equals 7. A is vector A represent ordered pair 5 2, vector B ordered pair 9 10. What is the required? Find V average. We know that, my dear student, from the average velocity equals R2 minus R1 over T2 minus R1. R2 position of the second point, R1 the position of the first point, or R2 position of the point B, R1 position of point A. Particle moves from A to B. What is the average? R2 minus R1, difference between 2 positions over difference between 2 times. We have 2 times, T2, T1. By substitution, the first point 9, 10 minus 5, 2, 7 minus 3, the second time minus the first time. Look at, my dear student, answer is 9 minus 5, 4, 10 minus 2, 8, 7 minus 3, 4. The average velocity 4 over 4 equals 1, I, 8 over 4 to j. The magnitude of the velocity by using square root coefficient of I square 1 square plus coefficient of j square 2 square equals square root 5 meter per second. Another example. Find VBA, same direction, VBA, opposite direction. What is the meaning of the velocity VBA? In this example, the required VBA. What is the meaning of VBA? My dear student, if you have a car and drive your car with velocity 80 meter per second, and another car in front of your car with velocity 100 meter per second, VA or velocity of your car equals VA equals 80. VB, the velocity of the car in front of your car, VB equals 100 meter per second. We represent velocity of your car according to velocity of the car in front of you car is VAB. What you meaning of VAB? VAB is the relative velocity, VA respect to VB, or velocity of your car respect to velocity of the car in front of you car. This is VBA. VBA not equals VAB. Why? Because VAB equals VA minus VB. Velocity of the first minus velocity of the second. And VBA equals VB minus VA. This is different between VAB and VBA. This in opposite direction. My dear student, look at the solution which represent relative velocity between two bodies. VBA in same direction, VBA opposite direction. My dear student, look at the solution. VBA in same direction equals VB minus VA. This rule by subtract equal 30 unit vector. VBA opposite direction equals VB minus VA. In opposite direction we change 7 unit direction. My dear student, look at another example. We have graph represent S and time. S and time, distant time curve. This curve is called distant time curve. Look at the time from 0 to 6. Distance from 1 to 6. Look at, my dear student, if t equals 0, s equals 0. T equals 1, s equals 4.5. T equals 6, s equals 0. Understand, my dear student? This curve, ST curve, represent the relation between S and T. VA from 0 to 3. Look at from 0 to 3. From 0, what is the S when T equals 0? We find SF minus ST over T2 minus T1 by substitution from the curve -2 minus 0, 3 minus 0, answer is -2/3 unit vector. This is deceleration. VA in magnitude 2/3 meter per second. Find number 2, VA from 0 to 1. We find when t equals 0, when t equals 1, by substitution, 4 minus 0, 1 minus 1, 1 minus 0, answer is 4 over 1 equals 4 unit vector. Therefore, VA is accelerated. Why? Because VA is positive more than 0, accelerated. If VA smaller than 0, decelerated or retardation. VA from 0 to half equals 2 over half equal 4. V initial equal 2 over half equal 4. This is the velocity after half second. My dear student, look at the opposite figure represent a stone projected upward. We have ST curve, a stone projected upward. When t equals 5, stone reach 122.5 meter. When t equals 2, look at the point. When t equals 2, the distance is 78.4. When t equals 8, my dear student, also the distance is 78.4. What is the difference when t equals 2 and when t equals 8? T equals 2, same distance. T equals 8. How? When t equals 2, the distance 78.4 up. But when t equals 8, when the stone return after 8 seconds, he reaches the distance 78.4. Then, what you mean? When t equal 8 equals when t equals 2, the same the distance. The distance up and the distance down. Distance up when t equals 2 is 78.4. Distance down when stone is returned back, when t equals 8, the distance is 78.4. My dear student, S equals 49t minus 4.9t square. When t equals 0, S equals 0. By substitution about t equals 0, then when t equals 0, distance equals 0. The curve represents S equals 49t minus 4.9t square. When t equals 0, S equals 0. Velocity ds over dt. What is the relation between the velocity and displacement? Velocity differentiation distance respect to time t. Therefore, velocity equals ds over dt. What is the differentiation of S? 49 minus 9.8t. This is velocity. Therefore, distance equals negative 9.8. This is decelerated or retardation. VA in this case smaller than 0, then the motion is decelerated. Maximum distance when V equals 0. What you mean? When a stone projected upward to reach maximum distance, then velocity equals 0. When a boy project a stone upward to reach maximum distance, then in this case the velocity equals what? Final velocity equals 0. Velocity equals 49 minus 9.t equals 0, then time equals what? 5. Then what you mean? The stone who will reach maximum height at t equals 5. Maximum height, velocity equals 0, t equals what? T equals 5. Then maximum when s equals 5, by substitution in distant when t equals 5, when the first function 49 times 5 minus 4.9 times 5 square, answer is 122.5 meter. Then the stone reach to maximum height 122.5 meter when t equals what? T equals 5 seconds. When s equals 78.4, then we find the time when distance is, or when a stone reach to distance 78.4 by using substitution about the first equation. 78.4 this distance equals 49t minus 4.9t squared. By substitution or factorization when s equals 78, therefore, my dear student, by substitution t squared 10t plus 16 equal 0. T squared minus 10t plus 16 equals 0 by calculator or factorization. T equals 2 and t equals 8. When, my dear student, t equals 2, the distance is 78.4. When t equals 8, also s equals 78.4. T equals 2 when projected upward. When return, t equals 8, the distance also 78.4. Find the velocity after 2 minutes equals 29.4 meter per second. Stone move with velocity 29.4 meter per second when t equals what? T equals 2. Also, when t equals 8, by substitution equals negative 29 meter per second. This is retardation. In return, velocity equals negative 29, but in projected upward, the velocity after t, its velocity was 29.4 meter per second. But V8 equal negative 29 meter in opposite direction, or when a stone is returned back. My dear student, when a stone return back, s equals 0, when time equals 0, then or t equal 10 seconds. V naught equals 29. Look at, my dear student, the curve is VT curve, the relation between the velocity and time. The initial velocity V naught equals 49. When t equals 0, the velocity or initial velocity equals what? 49. At point V, when t equals 6, what is the velocity? Equals 0. When t equals 8, the velocity equals negative 29.4. When t equals 10, the velocity was negative 49. Why? This is opposite direction or retardation. Look at, my dear student, when v equals 0, at t equals 5. Therefore, maximum distance equals area of triangle OAB. Area of triangle half base times height. By substitution, half base 5 times height 49. Answer is 122.5 meter. This is distance from A to B or from the initial to point B. S from 0 to 9 by using half times 5 times 49. This 122.5. Then we can calculate the distance of the body by using half base times height or area of triangle. Area of a triangle equals 122.5. This is displacement. Look at, my dear student, this example is very important. In the opposite figure, my dear student, curve, my dear student, is velocity time curve. Velocity time curve. Time is horizontal, velocity in vertical. My dear student, V equals 0 when what? When t equals 1 or t equals 5, t equals 0, and t equals 7 or 8 and 9. Look at, my dear student, the velocity equals 0 in 3 cases. When t equals 1, t equals 5, t equals 7. My dear student, V initial equals 0 at t equal what? At t equals 6. But my dear student, V more than 0 at t equals 0. More than, velocity more than 0 at t equals 0. T belongs open interval. Half open, 0, 1. Look at from 0 to 1. The velocity up straight line t. And from 5 to 6. And t equals 6. When V smaller than 0, under the time from 1 to 5 half open interval, union 6, 7 open interval. When A equals 0, when T belongs to open interval 2/3. My dear student, by the end of the lesson, we know that the relation between velocity and acceleration and displacement. We have 3 rules, very important rules. V equal V naught plus AT, S equal V naught T plus A plus half AT square, V square equal V naught square plus 2AS. 3 rules, very important, these motion rules or equation of the motion rule. My dear student, I am very happy to spend such time with you. Thank you. Goodbye.